Hello everyone, welcome back to Mathematics. So today's video will be focusing on this year's trial paper for Negeri Sembilan paper 1. So I'll rate this paper's difficulty as 3.5 over 5 because I think some of the questions are quite straightforward, but some of the questions will need some thinking process, then only can answer the questions. Right? So without wasting time, let's dive into it. For our first question, it comes from the chapter vectors, and here we have a vector and we need to prove whether it is a unit vector or not. Alright, so recall back, unit vector actually takes one unit from its original vector. So here the main point is, for unit vectors, the length or the magnitude is 1 unit. Right? So recall back, how do we find magnitude is using this formula. So x squared plus y squared, then square root. So the values of x and y actually comes from the values of vector I and vector j. So here our x would be square root 3 over 2 and y would be negative 1 over 2. So now what we need to do is we need to first sub the values of x and y first, and then we calculate to see whether it is 1. If yes, then this means the vector here is a unit vector. Alright, so let's do this. Magnitude, we sub the values of x and y, square root 3 over 2 and negative 1 over 2, square them, add them up together, square root, and then you will calculate that the final answer is 1. Right? So this means that this vector is a unit vector. Alright, and then here we need to justify our answer, so we can write out a simple conclusion. We can say that yes, it is a unit vector because the magnitude is 1 unit. For part B, we have a game, so the player has to push their marble to this point P or the goal, but they need to start from the origin, which is here. Okay, so the correct direction or the correct vector to push the marble would be something like this, right? To point P. So for this game, it only gives the player 2 trials, and we have a player named Aiman. So for the first trial, he pushes the marble in this vector, 3, 8. Then for the second trial, we don't know, okay, which is in PQ. But at the end, Aiman has successfully pushed the marble to the goal, which is point P. Right? So now we need to find the value of P and Q, the second vector. Right? So to find this vector, let's understand Aiman's first vector first, okay, which is this one, 3, 8. So the value on top here represents the movement if the marble goes to the left or to the right. So if it's a positive value, means we are going to the right by 3 units. Okay, so 1, 2, 3. Then for the bottom value here, it represents the movement going down or up. Alright, so if it's 8, means we are going 8 units upwards. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. So you can imagine that the first vector looks something like this. And since Aiman has successfully pushed the marble to point P, so you can imagine that the second vector looks something like this, right? From here to the goal. So now if you notice, the vectors if you combine, the red vectors if you combine, the starting point is O and the ending point is P. Actually same as the correct vector that we need to push, which is from O to P. So since both of the vectors have the same starting point and the same end point, we can form an equation where if I add this vector and this vector together, it will be equal to this green vector, right? Because again, both of the vectors have the same starting point and end point, right? So we can add these two vectors first, which is in this way, and using the column vector method, then I need to equal with the green vector. Okay, but the green vector we don't know yet, so let's find out the vector. Okay, so let's start off with the number on top. So here it controls the movement to the left or to the right. So here obviously it's going to the right, so we need to count the number of steps. Okay, here it's 8. Then here for the bottom part, it controls the movement to downwards or upwards, right? So here obviously is upwards, so 1, 2, 3, 4. So the bottom value is 4. So our vector would be 8, 4. Okay, so once we have our equation, it will be very straightforward. You just need to move this vector to the other side and minus them together to find the value of P and Q, okay, which is 5 and -4 respectively. So if you want to double check your answers, you can refer back to the diagram here. So since the top value is 5, we need to go 5 units upwards. Then the bottom value is -4, means we are going to move 4 units downwards. As you can see here, you have reached from here to the goal. For the second question, here we touch the functions chapter, and here we have two functions h and g, and we need to find the composite function, which is g, h, x. Okay, so for composite functions, we need to look at the function which is at the inside, which is h of x. Okay, so what we need to do is to substitute the function inside h of x with the value here, 2x minus 1. Okay, then we need to apply function g. So by applying means all the x, we need to change it to the new x here, which is 2x minus 1. Okay, so here -4, then the x here we change it to this one, 2x minus 1, and then we add a plus 2. And then we simplify, then we'll get this answer. And for part B, it says, hence, find the value of x if this happens. Okay, so if you notice, the function here is same as the function in part A. So we can use the final result here. But it's just that the value x is x over 2. So for the x here, we need to change, okay, from x to this value. So once you reach here, then you can just simplify and you'll get your final answer for x, which is 1. For the next question, focuses on progressions, and here we have an arithmetic progression. So this means if you want to go from one number to a next number, we need to add or minus a number. Okay, so for this progression, we have two important information. So for the first term, which is our a, is -64, and the common difference, which is d, is 7. And it also says that the number of positive terms in this progression is 3 over 2 times of the negative terms. So this means for this progression, positive terms is more than the negative terms by 3 over 2 times. Okay, so for part A, we need to find the number of negative terms. So before we answer this question, let's understand the progression a bit. Okay, so we know that it starts from -64. Then if we want to find the next number, we need to keep on adding 7. So for example, -57. Then add a 7 to get -50, and so on. So it will reach until a certain point, right, from negative number to a positive number. So for example, here, we will reach -1 if we keep on adding 7, but once we add another 7, it will jump to a positive value. Okay, so for part A, we just need to find how many terms are negative. So from -64 until -1. So we have two ways to solve the question. So the first way is to list down all the negative terms one by one until -1, and it cannot have dots. Okay, so later on, you need to count the number of terms that you have just written. Okay, and that would be your answer. But I do not recommend this way because I would say it applies to only some of the questions. So what if the question tells you, what if the answer has 100 negative terms? Of course, you wouldn't write out all 100 terms because it will be very time consuming, right? So I'll propose another way using the formulas that we have learned in this chapter to find out the answer. Okay, so here the other way is to focus on the last negative term in this sequence, which is -1. Okay, so what I'm interested is the nth term of the last negative term. The n here is what I'm interested. Okay, because let's say this -1 is the 5th term, so n is equal to 5. So this means this sequence has 5 negative terms. because this value is the last one. So what is the nth term will determine how many terms which is negative. Okay, so to solve this, which is to find the last negative term, we can use this inequality, which is Tn less than 0. Okay, it basically means we are finding the last term which is less than 0, or meaning negative. Okay, so here we can use the formula for Tn in arithmetic progression, which is this one. Okay, and then we just need to substitute the values of a and d, which is negative 64 and 7. Then we just simplify. But here the n must be an integer, right? So we need to find the largest integer but is smaller than 10.14, which is 10. Okay, so our answer would be the number of negative terms is 10. For the next part, we need to find the sum of all positive terms, but before we find the sum, let's find out how many terms that we need to add up, right? So here we know that number of positive terms is 3 over 2 times of the number of negative terms, which we have found in part A. So here to find the positive terms, we just 3 over 2 multiply 10. Okay, so we have 15 positive terms and we need to add them up together. But the issue is these positive terms are not in front of the sequence. Okay, I would say it's actually at the middle and the end of the sequence, right? So here we have 15 values that we need to add up. So how do we add up the middle values? Okay, so a technique is we find the sum of all the terms first, and then I minus out the terms that I don't want. Okay, so as you can see here, this sequence, we need to exclude the first 10 negative terms, right? The 10 values here. So what we can do is we find the sum of all the terms first, then I minus out the first 10 terms. Okay, so here the technique is to find the sum of all 25 terms, then I minus out the first 10 terms. Okay, so I can use the Sn formula from arithmetic progression, which is this formula. So n, I can just use 25, and then a and d would be the negative 64 and 7 here. Okay, same goes to S10 as well. So once you simplify, you'll find out that this part would be 500 and this part would be negative 325. Okay, it makes sense because we are summing up all the negative values. Okay, so negative, negative, positive, then you will end up 825 as your answer. Fourth question, we will focus on indices, surds and logarithms, and for part A, we are focusing on surds, okay, because we have square roots there, right? So to solve surds, we need to get rid of the square root. So to get rid of the square root, we need to square both sides. Okay, so for the left side, it will be something like this. We have these two things, 2 square root x minus 1. Then we need to cross multiply lah, right? So if we cross multiply this one, it will be 2 times 2, 4, and then square root x multiply square root x would be just x, right? And then here we need to multiply this value with this, so it's negative 2 square root x, and this value with this value will be negative 2 square root x. So you add them up together, it will be negative 4 square root x. Okay, then later on we need to multiply negative 1 with negative 1, so here it's positive 1. Right, just in case you're not sure how to cross multiply this. Right, and for right side, quite straightforward, it's just square root, cross off with the square. Okay, so you have 4x minus 9. Okay, then later on you just cross off the 4x for both sides, move the 1 to the other side, then you'll get something like this, and then the negative 4 you move to the right side, and the square root you move to the right side, then you'll get your final answer, which is 25 over 4. Part B is to solve a logarithm question. So we are given a logarithm and then we need to express this logarithm in terms of k, which is the given logarithm here. Alright, but as you can see, these two given logs, the base value is different. Okay, one is x and one is 4. Right, so now I like to let you all know what are the 3 main steps in order to solve any kind of logarithm question. Alright, so the first step is to change the base. So change the base meaning I would change my 4 to the given log space, which is x. Okay, so from the 4 I would change it to x using this formula. As you can see here, the old base, which is a, then I change it to the new base. Okay, so from 4 I change it to x. Then for the value here, I'll put it on top, and the old base I'll put it at the bottom. So this cube root of x, I'll put it on top, 4 I'll put it at the bottom. Right, so this is the first step. Second step is to manipulate, meaning using these formulas to simplify the expression here. Okay, so one of the things we can do is this cube root. Because this cube root, we can change it into this way, right? X to the power of 1 over 3. And since this is log, we can move the power from this formula, the power from here, I can move it to the front. Okay, so you can imagine that this cube root of x becomes x 1 over 3, and then I move this 1 over 3 to the front. Okay, as you can see here. So now the logarithm is the base and the value is the same. Okay. This also brings us to another characteristic of logarithm, which is if you see the value and the base is the same, then the value is 1. Okay, so this later on will become 1. And the denominator, I don't change anything first, because as you can see, the denominator is has the same expression with the given log here, right? Because this one is log base x 4, which is equals to k, so this part I will change it to k, as you can see here. And this 1 over 3 will be divided by k, so I just pull the 3 down. Right? And this will be your final answer. But you may be wondering, how about the third step of this one? Because you already found the answer. Okay, so for this question, we don't need the third step. So third step is actually changing the form. Okay, changing the form means from logarithm format, I change it to the index format. Okay, so example, let's say we have this log. Okay, and then to change to index form, I just push the base value to the other side. So it will be y equals to, so when I push the a, it will be here, and then this x will become the power. Okay, so this is the index format. So for some of the questions, we might need to use this step to further simplify the equation and then to find the answer eventually. Okay, but for this question we don't need to, because this one is just expressing. Alright, so we can just skip the third step. And for the next question also touches the same chapter, right? So in part A we have this indices equation, and we need to express y in terms of x. So this means the only thing on the left must be y. The rest of the stuff must be on the right side. Okay, so if you notice this indices equation, the y here actually appears at the power part, not the value part. So what we need to do is to move this power to the front. And the only way to do this is apply log for both sides. So as we seen in the previous question, one of the formulas is if we have log, we can move the power to the front. So this y minus 4 move to the front, 2x move to the front. Okay, and then you'll get something like this. Alright, so later on we need to make sure y is the only thing on the left. So this log 7 I need to move to the right side. Negative 4 I also need to move to the right side. So you get your final result will be something like this. Okay, so all these values I can simplify to get this 1.129 here. And another thing to let you know is that this LG stands for log base 10. So it's one of the most common logarithms that we will use for SPM. Okay. For the next part is also a indices question. So here we can see that we have this expression and we need to show that whether it can be divided by 4 for any positive integer of x. So this means x can be 1, 2, 3, 4 and so on. It cannot be fractions or decimals, right? So to solve this kind of question or any question which are similar to this, it actually has a standard way of doing. Okay? So if you zoom into the indices here, the power consists of two values, x5, x3, x2. So the first step to do is split them. So we know that if we add, if we split, it will be multiply, right? So here, as you can see, it will be 2 power of x multiplied to the power of 5. Okay, same goes to the others as well. Okay, then you will see for each of the value here, we have 2x, right? So we factorize all these 2x out, okay, to become something like this. Then for the values like 2 to the power of 5 plus 2 to the power of 3 minus 2 to the power of 2, then we combine all of the values together and simplify. So you will get 36. So the most crucial part is to check whether this value can be divided by the value here. Okay? Because if I can prove this value can be divided, means this expression and the original expression can be divided by that value as well. Okay, so let us check. So 36 divided by 4 will be 9, right? So there's no remainder. This means 36 is divisible by 4. Okay, which also means both of these expressions can be divided by 4. Okay, I can show you a very simple example. So let's say I use 2 and I sub it inside the x here. Okay, so x equals to 2 and then 36 multiplied by 2 power of 2, which is 4. So here you will get 144. And then let me divide by 4 to see whether there is any remainder or not. Okay, there's no. So this proves that the expression here, okay, this expression and this expression can be divided by 4. Alright, so here we need to write out a simple conclusion, okay, for this kind of questions. So we can say that since this is divisible by 4, so this proves that the original expression here can be divided by 4. For the next question refers to linear law. So here we have two variables x and y, and it's related by this non-linear equation, because here we have the square, okay, which proves that it is non-linear. And in here we also given a diagram and it is plotted big Y against X. Okay, so for this big Y, right, it can consist of either X, Y, or both X and Y. Okay, so this is the thing we need to find out in part A. We need to express Y in terms of X or Y or both of them. Okay, so the big Y here refers to the Y-axis in this diagram. So for paper 1 questions in this chapter, I would say there will be only two ways to solve. Okay, either we are going from non-linear to linear or linear to non-linear. Okay, non-linear here refers to the equation here, linear refers to the line equation here. Okay, so non-linear to linear means, are we using this equation to find the equation here or the other way around? Okay, but I would say non-linear to linear makes much more sense, because if we go from this line to find the equation here doesn't make sense because we don't know the equation here, right? So here we can just cancel off this part and let's focus on changing this equation to find this line equation. Okay, so for the non-linear equation, it is this one, and the linear equation in standard form, it should be big Y equals to big M, big X plus big C, right? So here for the linear equation from this diagram, we have the big Y. Okay, so let's rename it first. For m we don't know, but we can just blank it first. The big X here, we can look at the x-axis here. So this one is a small x, which means the big X here is the small x. Okay, and then the big C here, if you see the y-intercept, it's 4. Alright, so we'll put 4 here. Okay, so once we have all the information already, we can compare the nonlinear equation to see what's the main difference. So here, if we look at the similarities first, we have 4 and we have x, but the only difference here is the x squared. Right, so what we can do is, to remove this thing, we can move it to the left side. Because for the big Y, we still don't know what it has. So we can just move the x squared to the left side. And to make sure that the right side has the same expression, which is the x plus 4 here. Okay, so if we compare these two equations, we can easily see that the big Y would be small y minus x squared. Okay, and by comparing, we can also figure out the gradient here, which is 4. Okay, so the big M here is 4. And for part B, we can use back the equation here to find the value of h, which is the x coordinate. Okay, because this coordinate is on the straight line equation, so we are going to use this and substitute the coordinates. So what we can do is, for the big Y become 5, small x become h. Then the gradient and the y-intercept will remain as 4, and then we can just simplify to find the value of h, which is 1/4. Question 7 focuses on differentiation. So here we have gradient of the tangent to the curve, which is this one. At this point is 5, and we need to express q in terms of p, so q must be on the left side. Okay, so the main point here is this one, gradient of the tangent to the curve, which we know it is dy over dx. Alright, so what we need to do now to figure out this thing is to figure out dy over dx first. Okay, so we need to differentiate this equation. Right, so a lot of students, when they look at this, they will straight jump to use the product rule. Okay, but here we have a shortcut. We don't need to do this because the expression here is quite simple. So what we can do is just multiply the x squared to these two values. Okay, so it will be something like this. Then from here, you only differentiate. Okay, so here we can save a lot of time. So product rule might be time consuming sometimes lah, as you done the exercise before, right? Okay, so now let's differentiate this. So again, power I move to the front, and then I minus 1. Power move to the front, then I minus 1. So here will be 3px power of 2, and then here will be 2qx. Alright, so once we have this expression, then we can substitute the values we have here. So dy dx here is 5. Okay, and then the value of x here according to the point here is 1. So let me substitute 1, and then we can arrange this equation in a way q is on the left. Right, so this would be your expression. And the second part is we need to use the method of chain rule to find the first derivative of this thing. And so here we have a u, and then here says u is equal to 6 minus 3x. So this means u is dependent on x. Okay, they are not independent. U is dependent on x. Okay, so here first derivative actually means to find dy over dx lah. So we need to find this dy over dx using the chain rule method, which I have explained in my previous videos before, which is this 2s 2f method. Okay, so let's be clear on what we are trying to search here. So here is dy over dx. Okay, then we need to split the fraction. Okay, then we need to fill in. So here obviously we need to fill in u lah, right? Because that's the third unknown that we don't don't have in this equation yet. Okay. Then here we need to find these two differentials. Okay, so the first one is using y as the original equation, which is this one. Okay, so the u, I will move it out of the fraction, so it will become u power of -5, and then we need to differentiate this thing. Okay, so use the same way, power I move to the front, and then I minus 1. Okay, so in front here will be -5 over 2, and then u, and the power will be -1, so it's -6. Okay, so we've done this. Okay, for this one, we need to use the original equation, which is u, and then differentiate with x. So the things which have x, we need to differentiate it. Okay, so means this 6 I can just ignore, so I can just focus on the -3x here. So once I differentiate, because x don't have so the power of x is 1, so I can just extract the value. Okay, so it will be -3. So once we have these two differentials, we can just multiply them together, and you'll get your final answer, right? So 3 multiply 5 is 15, and 2 will be here. So this u part, make sure to change back to x. Don't remain this part as u6. It will be wrong, because here you have written that it is dx, not du. Alright, so once you put x, everything must be x at the last step. Okay, which is why this u, I change it using this one here. U equals to 6 minus 3x. That's why there's a 6 minus 3x here. Okay, so reminder, don't put u, put the expression that has x. For question 8, we are looking into functions. So in the diagram here, we have the graph for function f, and for part 1, we need to draw out the graph for the inverse function. Right, so recall back, one of the things that we need to have when we draw out the inverse function is the line y equals to x. Right, because if we have the original function, and the graph of the original function, we use this line, find the reflection, then we will get the graph of the inverse function. Okay, so let's draw out the y equals to x line first. So means joining all the points where y and x is the same, right? And then use this back line to draw out the reflection. Okay, and don't forget to label. And for the second part, we need to mark and label point A where these two functions is the same, or meaning they meet, or meaning they intersect with each other. So the intersection point would be here. Okay, so we will label this as point A. For the next part of the question, it's a K-bar question, so let's go through the paragraph together and let's identify the unknowns. Okay, so for the first sentence, it says this factory produces Q packets of sambal goreng. Okay, so Q is our first unknown. Then this production of the packets actually depends on the number of workers they have, right? So this is our second unknown, which is N. So these two unknowns can be related by this function, which is this. Okay, so this means I need to know the N, only I can know Q, right? Because the number of workers that I have, then I can determine how many sambal goreng that can be done from these workers, right? So this is the first functions relation. Then if we go through here, it says total profit per day, which is the third unknown, which is R, is received from the sale of the sambal goreng packets, right? And you can see that it relates the packets of sambal goreng with the profit, okay, which is the second function here. So this means I need to know the number of packets produced, then I can only find the profit, right? So this is the second relation. So for the first part of the question, we need to find out what are the number of workers required to produce this number of sambal goreng per day, right? So number of workers here would be our n, and the number of packets is q. Alright, so since I have no q's number, then I can find n's number, right? So we need to find a function that relates q and n, which is this first function, right? So for the q here, I can just substitute 500 inside, and then I find the value of n, the number of workers, right? So if you simplify, then you will get n is equal to 10. For the second part of the question, we need to find out the minimum number of workers required if the factory wants to produce a profit at least 116k per day, right? So the minimum number of workers here represents n, and the profit is r, right? So now we need to have a function that relates these two directly. But according to our flow here, we need to pass through q, right? Because it relates n and r. So what we need now is to have a function that skips q, just go from n to r. Alright, so what we can do is, because q is inside first and the second function, and the first function goes through only the second function, so what we can do is, first function substitute into the second function. It's like we are forming the composite functions. Okay, so again, composite functions is a function, but inside there are two functions. Okay, so to form composite functions, we need to put the one that we need to sub at the inside, okay, and the other function on the outside. So here what I will do is, for the function here, 200 plus 3n squared, I will sub it inside the r here. Okay, then according to the r's function, so this q has changed to this value, so this q I also need to change to this value. Okay, so the result will be something like this, and then I will simplify lah. So this thing would be the function which directly goes from n to r, right? So technically this thing is the profit already, according to the number of workers. So back to the question here, it says profit at least 116k per day. So what I can do is, for this part, just substitute here. Right? Then I simplify to get the value of n. So once we reach here, we need to move square to the other side. So once I move, there will be a square root here, and at the same time there will be plus and minus. Okay, so this means we have two answers. Right? So for the positive version, it would be straightforward lah. So square root 900 would be 30, and the sign doesn't change. So this one is n more than or equal to 30. But for the negative version, because we are moving a negative to the other side, so the inequality here, we need to change sign from greater than or equal to lesser than and equal. Alright? And then the 900 square root will become 30, and because we are moving negative to the other side, so here we need to put negative lah. Okay, but for this one, we need to reject, because number of workers cannot be negative, right? So our answer would be this one. And here, going back, it says find the minimum number of workers. So here, according to here, n must be at least 30. Okay, so we can write out a simple conclusion. Minimum number of workers is 30. For question 9, it focuses on the chapter Trigonometric functions, and this question is an example of expressing values or functions kind of question, right? Because there's a word express here. So here what we need to do is express these two trigonometric functions in terms of p, and p comes from this clue here, where cos theta equals to p, and the theta or the angle must be between 0 and 90. So when I look at this kind of clue, right, what I will do, and I hope you all make it as a habit, which is to draw the triangle at the ASTC diagram, or the quadrant 1, 2, 3, 4 diagram, which is, for example, quadrant 1 is 0 to 90, and quadrant 2 is 90 to 180, and so on. right? So since our theta is from 0 to 90, so our triangle should be drawn at this first quadrant. Okay, then I label this as theta. So another thing we need to know is the cos theta is adjacent divided by hypotenuse, right? So if cos theta is equals to p, this means the adjacent should be p and the hypotenuse should be 1, right? So I can label these two lengths here. Okay, and then there is one more length here. So what we can do is use the Pythagoras theorem, because this triangle is a right angle triangle, right? So 1 square minus p square, and then we square root. Right? So now going back to here, this function actually looks a bit similar with the other formulas, the trigo formulas in the formula sheet, right? Because here we have two angles and there's a bunch of formulas that has this pattern, which is the formula from 35 to 37. As you can see in the bracket, there are two angles. Okay? So maybe there's a way which is using cosecant. Maybe you can change it to sine, because cosecant is the inverse of sine, and then we can use the formula here. Okay, but before we go into that, if you look at the mark, it's only one mark only, so it shouldn't be that troublesome using this formula to find the answer. It should have a much more straightforward way. Okay, so yeah, this is the part where I think a lot of students will miss out the formula, because these formulas are not in the formula sheet, but it's in the textbook. Okay, which is these formulas. Okay, so these formulas are actually called complementary angles. Okay, so if we look back to here, cosecant, so now you have cosecant and it's 90 degrees minus theta, so it's exactly the same as the expression here. Okay, so this means we can straight change it to secant theta, right? So we change it to secant theta, and we know that secant theta is the inverse of cos, right? So we can change it to 1 over cos theta, and we know that cos theta is equals to p, so we can straight change it to p, right? So this would be our answer, and it has a much more straightforward way. Right, so if you have difficulty in memorizing all of these formulas, I recommend to use this trigo hexagon. Actually, I have taken this from textbook in the English version or the Malay version, which is at page 193 and 212. Right? So how do I use this hexagon to memorize all of these formulas? Is I look horizontally, right? For example, like this. Okay, for the one we first ignore first, okay, because the one there is other usage, but it's not applied here. Okay, so if you look at the functions which are related, which is sine and cos, you can see that it also matches with here, sine and cos. Tan, cotangent, tan, cotangent. Secant, cosecant, secant, cosecant. So this hexagon is a very useful way to memorize, right? And there are a lot of functions for this hexagon. For example, these functions here, which we will use a lot, actually can be also use this hexagon to memorize. Okay, but this one we look using the diagonals, right? Which is like this. Okay, and this time we need to use the 1, right? So this means sin theta would be 1 over cosecant theta, which is the expression here, right? Another example, if I use starting from cos, cos theta would be equal to 1 over secant theta. And there are a lot of formulas can be memorized using this hexagon, so I would recommend students to use this hexagon more frequently, right? Alright, second question, sine 1 over 2 theta. So this is a half angle function. So according to the list of formulas that we have, we can use all of these. Okay, it's just that because it is divided by 2. So for all the angles here, we can all divide by 2. So let's imagine all the a's has become a over 2, and those which are at 2a will become a, right? So now, if you want to find this function, we can use these formulas, but we need to choose which one would be the best one. Alright, so if we scan through all, the ones that have sign would be this formula, and this formula, right? Okay, so among these three formulas, let's choose the one that has the least trigo functions. Okay, so for the first one, we have 1, 2, 3. Second one, we have 1, 2, 3. Okay, third one, we have 1, 2. Okay, so we should use this one. Okay, so to avoid confusion, all the a's we divide by 2 first. Okay, and then let's use it here. So I changed the a to become theta first because the question uses theta, right? So now we need to find this, okay, the sine theta over 2, and we don't need the square. Okay, so what we should do is we move this part to the other side first. Okay, and then we slowly move the things to the right side. Okay, for example, the 2 and then the square root. Right, so square root, when I move, usually we will have plus and minus, right? But because of this angle here, the angle is 0 to 90. So sines, as we know, sine in the first quadrant, it is positive, right? Because in this quadrant, sine, cos and tan is all positive. So here, there's only one answer, which is positive. Okay, so I do not need to write the plus and minus here. Okay, so now once everything has moved to the right side, which is this would be the thing that we want, so we just need to change the cos theta to the given clue here, which is equals to p. Okay, so our final answer will be square root 1 minus p over 2. For question 10, it focuses on integration. Alright, so in part A, we are given this a bit complicated equation, right? And we need to find the value of this integral. Okay, let's go back to the equation here. Okay, so usually we always look at dy over dx, right? So if we compare dy over dx with the thing on the left here, you can see that y is the original equation and it's equal to this thing here. Okay, so this is the original equation. So d over dx here means if I differentiate this original equation, I will get this 4g of x. So this is the result after I differentiate. Okay, so if I draw this diagram out here, so this is the original equation. If I differentiate, I will get this equation. But if I want to go from here to here, I just use the integration way to get back the original equation. Okay, so that is the way to understand this. Right, so now going back here, we need to find the integral of this. Okay, so here in the integral we have two values here. Okay, so what we can do is we split to become two integrals. Okay, so this means one focuses on 2g of x, the other one focuses on 1. Okay, but I separate using plus here because there's a plus here. Okay, so now if we compare the 2gx here, the equation gives, the clue here gives us 4g of x. Okay, so what we can do is we adjust the value a bit. Okay, but here we need to have, in front we need to have a value which is 4 multiplied by what value to become 2. Okay, so here will be 1 over 2 lah, right? 4 divided by 2 equals 2. Then for the second integral here, I don't change anything. And now once everything is settled, then I start integrating. Okay, so here if I want to integrate 4gx, if I look at the diagram here, I integrate, I will get this result. Okay, so this is the integrated result. So I don't need to do any integration because this is the result already. What I need to do is just 2 and 0 I put on the edge. Okay, and here I remain the 1 over 2. Okay, so for this one, it's normal integration. So here, since it is only a number, so I need to add an x for it. Okay, and again 2 and 0 I just put on the sides. And here will be much straightforward already. It's just I substitute the two values inside and then I minus them together. Okay, something like this. 2 substitute, which is this one, and I minus when I substitute 0. Same goes to this one as well. Alright, 2 minus 0. Then you simplify, then you'll get your answer, which is 25 over 9. For the next part of the question, we have this, again a complicated equation, and we need to find the value of p if k is equal to 4p. Right, so let's rewrite this equation and let's change all the k's to become 4p, something like this. Okay, so I would agree that if you see the functions which is exactly the same, for example here is AP4P, AP4P, inside the integral is f of x, you would cross it out, right? Okay, but here we need to use the integral way to cut off these two. Okay, so what we can do is we can combine these two integrals together using a method. Okay, so here, if you want to combine, right, this value and this value must be the same. But currently it is not, right? So what we can do is, because here it's minus, I can change it to plus first. Okay, I change the sign means that I can change the sequence of these two numbers. So here will become 4p and here will become 8p. Okay, so now you see that this value and this value is the same. Okay, so once these two values are the same, then I can combine these two integrals to become something like this. Right, so inside the integral it will be the same, which is f of x dx. Then here for the upper limit, I will use this one. The lower limit, I will use this one. Okay, and then don't forget the 3p. Oh, sorry. Alright, something like this. So if you see the integral, upper and lower limit is the same. And we know that if upper and lower limit is the same, the value is 0. Okay, so this part will become 0. So here we can just ignore, we can just simplify this part to get the value of p, right? Which is 1 over